Welcome to AE². I'm Isaac with AdvancedTek. I do applications engineering, and I also do service work on the F-series and J-series systems. Today we're just going to talk about bonding, some best practices for sectioning your parts, and if you should use epoxy or if you should hot air weld or whatever else you want to do to get your parts put together. We don't do a ton of sectioning here or bonding parts here just because we have the benefit of having two F900s. As you can see back here, we got a couple of those and an F3300, so we can build large format parts pretty easily. A little background on me: I actually used to work at FDM doing a lot of part finishing, and the hot air welding was a staple in a lot of the stuff that I did. I've welded a lot of different parts, large parts. We did a little project back in like 2008 where we put together a fully assembled turboprop engine. So I had to bond all of those parts together. It was like 100 parts, but it was all hot air welded and solvent bonded. So a lot of experience behind the hot air gun. So I just wanted to jump in, and we can go right over to GrabCAD print. I'll start sharing my screen here. So I'm sure there's a few of you that have F-series and you've got a part that you've tried to build and it's just too large. So you're trying to figure out how you should section it and how you should, what maybe epoxy or glue or solvent that you want to try to use. I've pulled up a tray here. So these are just some larger parts that I've done. This one, I've already redone this section here in my Fusion software. So I'm sure there's some of you that have probably done, or I'm sure some of you use like Fusion or SolidWorks or Creo or whatever. And sectioning parts in there can be a little bit more intuitive. And if you have a feature somewhere inside of here that you need to avoid with your section cut, that can be a little bit easier, and you can put clearance in and do the correct joint for the part that you're trying to do. So something like this, you can see that post and hole is probably going to be the best fit. I've added some clearance in here, so if I were to do this in real life, I would probably either solvent bond this or epoxy weld it. And then I have another large part here, and I just wanted to go through the sectioning tool that's in GrabCAD Print, in Print Pro. So I can go in here and select my part, and I can say split model, and it will ask me in which direction that I want to split the part. And for this instance, I'm going to say Z, and then it will you can just use the cursor to get to the correct height. Maybe you had a feature in here you're trying to avoid, or you just want it to split right at the top of the platen or whatever. That doesn't really matter all that much. But the next tab here is add registrations. So if you had it where it had to be clocked a certain or indexed a certain direction, or it could only fit a certain way, you can add these registrations however you see fit, just so it goes in the right direction. And then these have adjustments, so you can make them smaller, taller, shorter, or add more clearance depending on what type of technology you want to use to bond them. So a little less clearance if you're using solvent, a little more clearance if you're using epoxy. But to apply those, you just click, apply them wherever you want them. If you do 3 of them, you can only put it on one way pretty much, and then hit split model. And then you have your 2 parts ready to be printed. And then once you're done, you can go ahead and bond that together however you want. So I kind of went off and just kind of started talking. If you guys have any questions, you can type them in the chat. And then if you want to unmute yourself too, I'm willing to take questions. It's kind of rapid fire. I don't have a problem with that. So, but wanted to let everybody know. So that is GrabCAD Print, just doing the generic sectioning in here. I wanted to open up Insight. We can do another type of section in here. All right. So I want to open this part so you guys can see the error I get when I open. So if you have a part that's too big for the platen when you open Insight, it will give you an error and say it's too big in whichever direction that it's too long. In this instance, it's X. And in Insight, we have the ability to come in and section this part however we see fit. There's a couple different tools here. One is section with profile. You'll notice that the Insight kind of looks a little bit old school. That's because it was designed before Windows XP came out. So just bear with me on that. But it is very powerful. So go ahead and start your section. You just go to Slice, Section with Profile, and then you'll get this toolbar at the right-hand side. And it's going to tell you what it's going to save the left and right side as when you do this cut. You have a couple different drawing styles you can use here, but I usually just do snap to grid if I'm making a generic dovetail. So something that's long and flat, you don't necessarily want to have it be a straight edge cut because there's really nothing for the bonding process to hold on to. If you're using epoxy, that'll be a weak joint. And if you're hot air welding, it could lead to a little bit of potato chipping and stuff like that. So I'll just show you what I would recommend for larger flat parts. I usually just do a dovetail, just create a few points. This is probably going to look a little bit hokey, but bear with me. And then that would be our section cut across the part itself. And then once you hit OK, it will save these parts to that base directory where the initial job came from. So now you can see that we have a section part that would be ready to be hot air welded or solvent bonded or epoxy bonded. The only problem that I have personally with doing it in Insight is that there is no clearance on the seam to seam. So when you try to fit this together, it's going to end up fitting a little bit tight. So at that point, you'd have to do a little bit of sanding, especially in the inside corners. You'd have to do some sanding there on the outside corners to get everything to fit. But it will be a nice, clean seam when you're done, once you're done sanding and everything. I'm going to reopen this file again. There's also another section tool, which is nice for bulky parts. I'm going to stop sharing for just a second here. So this seam actually gets created. I had to go check out all of our parts in the lab so I could get a good example, but this is the section with registration tabs in Insight. So this is the default type of registration that it makes. It's just kind of a sawtooth. And it fits together really, really nice, as you can see here. And this would be good for solvent bonding or epoxy bonding, just because it's a nice mating surface and it increases that surface on there. This is a pretty nice way to do it, and I'll show you how to do that inside here quick. Make sure my parts don't fall off my desk. Oh, here I got a couple questions. Can you draw a radius in Insight that to make a dovetail or just straight line segments? You can, but it is based off of point. I'll show you here. If you do that section with profile, you have to create the points yourself. So not super intuitive. Like I said, it might look a little hokey when you're done. That's why I recommend, if you can, to section your parts in your native CAD using this dovetail. That way you can maybe put in 1.5 thou or 2 thou clearance in there. Oh, not sharing my screen. Thanks. I don't usually do a lot of these, so doing my best. But yeah, so you can just kind of draw it generically like this. And if you do it correctly, it should look more like that if you're doing it correctly, and not like my drawing. But then that's the kind of joint that you would want to do on longer skinny parts anyway. That way you get a little bit more flexural strength this way when you're trying to, once it's done, so you don't have to worry about it breaking on a straight edge. Let's get back to my screen. All right, so if you can do that, I'm going to reopen this again. And then the next question is, how do the welding methods compare for strength when looking at solvent weld versus epoxy versus a purpose-made like 3D glue? I personally don't, I've never used 3D glue, but the solvent weld for ABS and ASA and some of the PC ABS blends, it works pretty good if you have a lot of surface area, and it does have fairly decent tensile strength. Unless you get some heat applied to it, then it can start to weaken that bond a little bit. The epoxy is like a high salt product. It's 93, 94, and that one has excellent tensile strength and it's got good temperature resistance. I would prefer, if I'm going to have a mechanical part that's going to see a lot of load, to use epoxy, just because it's stronger and has more longevity, where the solvent is just more for quick repairs or just quick seaming parts that maybe are just for display models or something like that. But okay, let's get back to what I was trying to do. Close, reopen that file again. Boom. All right. And then here is the section with profile. We're going to apply registration features, and you can just click anywhere and it generates a straight line across the part. Okay. And now you can kind of see here those generic sawtooth patterns within that part. So I have a little link to a YouTube video here that I want to bring up, and this just kind of shows the hot air welding process. So hot air welding is a little bit difficult. You have to practice a little bit. You're using the filament off of the spool. So if you're building out of ABS, you're going to grab a piece of filament off of your ABS spool. Nylon, same thing, you use nylon. The hot air gun is made by, the one that we prefer to use is made by Leister. It is a little bit expensive, and it has multiple tips with different diameters for the type of welding you're going to do. We used the one that's, I want to say it was an 1/8 inch orifice for that one, and that one seems to work pretty much the best. They are, like I said, they are a little bit expensive, but it is a pretty useful tool. You can use this for bonding. You can also use it for if you had a sanding scratch or something on one of your surfaces that you wanted to try to remove some blemishes, you can actually reheat that blemish and kind of do like a flame polish with that. So, all right, and then here's my little link to the video on Stratus Academy. This web, or their little YouTube page is pretty good. They've got a lot of good stuff on here. I found this just by looking around, and they do a good job of showing how to do the hot air welding kind of step by step. So I'll just fire that up here. So here you can see they've just done a generic dovetail. It's got a little bit of clearance on there. And in this instance, I think they were just doing black ABS. So it's a little bit easier to weld this than like nylon or Altum. So basically you want to start on a flat table, piece of granite or something like that, but you'll just want to tack weld the outsides. That way you can kind of get it, make sure that's going to stay nice and level. And then you just work your way in, tack welding just small places at a time, keeping certain that the part is flat. And then you'll start running your beads after you get kind of everything fixed in place. You don't want to do large welds at a time. If you can, minimize it to like 3-4 inches at a time, that can help minimize some of your warping that will occur with any type of welding process, whether it be plastic or metal. So here you can see what he's trying to do is heat up the material in front of the filament and the filament at the same time while applying downward pressure. That way it gets good penetration into the material so it can adhere a little bit further down within the part. When you do that, though, it does create a little bit of a void. So you have to come back and fill it again after you've done the initial weld to bond the part. Once you're done, he's just using a roll-lock disc sander to knock down the high parts of the weld. And it's pretty, it, it, it seems like it might be easy at first until you dig the edge of the roll-lock sander into the part and you get a big groove, and then you got to go back and fill that with some more weld. But it takes a little bit of practice, but once you get it, it's really a nice way to get parts bonded. And then you just take your DA sander and sand everything flat, and then that's what you should be left with. It's just a nice, clean looking part. So the solvent bonding step here, this is what you would do on the back side of a weld. If you were doing the hot air welding with ABS, you would put this on here on the back side just to kind of close that all off. And like I said here with the solvent bonding, you just want to make sure that you've got a lot of surface area and a little bit of a registration feature like that dovetail. Overlap joints are also really good for solvent. If you can use an overlap joint that you can design in your SolidWorks or Creo or whatever you have, that's going to probably be the best for the solvent. Have I tried using a pen to weld parts together? I've used patch holes. I haven't tried it to bond parts yet. No, I haven't tried it yet. I don't know how well that would work. Just because you can't get the heat applied deep down into the part to get that to adhere together. I don't know. Yeah, if you do try it, I'd like to hear some feedback on it and see if it does work okay. I can imagine it would be good to fix blemishes if you had blemishes that you wanted to dig out. You could try to use that and then sand it flat. So then after that, I have a little bit of this is a bonding technical application guide. We also got this from Stratasys, but this just talks about the different technologies that you can use and what materials are compatible, because there's certain materials that you cannot use solvent on. So like Altum, nylon, PPSF, some of those. You can use polycarbonate. You can use solvent to reattach features, but it's not necessarily going to be a good bond. So there just goes through best practices in that. It talks about the high salt products that we use. And then there's some additional bonding methods that have been tried in the past. They're not as good as the three that we discussed here. So. And then from there, I think that was pretty much it. I was going to open it up to questions. If anybody wants to unmute and just jump on, we can just talk about stuff rapid fire, I guess. I'm okay with that. Anything else on there that I'm missing? That's about it. So these AE² events, sounds like we're going to do these monthly. Oh, can you show the tool for sectioning one more time? Absolutely. Do we want to do you guys want me to run through both GrabCAD and Insight again? I can do both. Okay, section profile. So that section with profile and Insight, you just go to your slice and then you do section with profile. And then you snap to grid, you're just going to draw just a little spline across. You know, you'd think I'd get better at making these dovetails, but I'm just struggling. Look at that. Terrible. My kids in here to do this, they'd do a better job. All right, there we go. And then once you get it drawn, then you hit OK. then that will save the right and the left section. You can name these whatever you want before you start that process as well. And then it will open the one of the sides first. The section with profile. And then what brands, types of solvent adhesive do you use for ABS? Good question. I'm going to stop sharing my screen here, and then I'm going to show you this handy dandy stuff. So this is Plastruct. You can get this at most hardware stores. I know you can get it online. McMaster-Carr has it as well. Fastenal, things like that. And then there's a brush in here. I mean, it's okay, but it takes a long time if you have a big part to bond it. I mean, it just looks like a nail polish brush. So it takes a while to get that to go across a part that's as big as an F-series platen. So I actually like to get these little needle bottles and fill these up with the solvent, just pour it in there. And then you can just squirt that right into the seam, and it gets a little bit further in there as well. So that is a couple of the brands there. So there's this Plastruct, and then there was one that was called Weldon. I believe Plastruct does work with PLA as well. I haven't experimented with bonding PLA parts before, but I think it would. It might be a little aggressive for PLA though. Oh, here. Yeah, should work. Oh, Phil just put up a link for the plastic weld or the Plastruct, and you can get it a lot of other places as well. So. Is there any other questions? Any questions with GrabCAD Print Pro or anything like that for the split function in there as well? Well, like I said, we're gonna do these monthly. So we just brought up some topics internally, like what we wanted to talk about. You know, whether it was bonding or we did the nylon thing, and some of those things can be kind of specific, and we just want to make sure that what we're doing is relevant to what you guys want to see and how you're using your machines. You know, we have a few topics in mind, but if there's anything that you guys would like us to address or talk about in these upcoming AE², we're open to some suggestions, so we can keep providing with the content that you guys like. So, but if there's no more questions, oh, got one more. Do you recommend adding dowels for thicker sections before bonding? Or have you had good enough results just using the sawtooth tool? I guess that depends on how much load is going to be on the part. You know, sometimes you get some parts that are pretty long and very dense, very heavy. If you can create a hole where you can put larger steel dowels in there, or even print plastic dowels on their side so they have a little bit better shear resistance, that would work. We have done that in the past where we're actually embedding hardware inside of the part, and that works too. Press-in inserts, heat stake inserts, we have done stuff like that as well. But the sawtooth tool does work pretty good because it does give you a little bit of shear resistance just by its design. So. Well, I wanted to thank you all for jumping on today. That was kind of a little bit of a quick overview. So if there was something that you had questions on, you can just email them over and I can reach out to you at a later date too, if you'd like. So, and if there's no more questions, I think that's about it. Thanks, everybody. I hope you have a great rest of the week and enjoy the nice weather, and maybe we'll avoid the snow and stuff that's supposed to come later this week.